All right, folks, welcome to section 9.4, hypothesis testing for a single population proportion. This is example number 3. It says here, in a study of 1,375 cell phone users, 11 of the subjects developed brain cancer. Tesla claimed that cell phone users develop brain cancer at a greater rate than for non-cell phone users. The rate of brain cancer for non-cell phone users is 0.5%. Since this is a critical issue, use a 1% significance level. Okay, population number 1 is going to look at this first sentence. That's the sample. So the sample always targets, describes, is extracted from the experiment group there, population number 1. For population number 2, that's the claim. Go to the next sentence there. Says the rate of brain cancer for non-cell phone users is 0.5%. So what we're going to do is compare here in both groups talking about that development for brain cancer, but more specifically cell phone users for the experiment group versus non-cell phone users for the control group. So you have sentence number 1, sentence number 2. Therefore, we want to start out with the same verbiage saying the set of all. So for both of these groups, we're looking at the set of all subjects there that develop brain cancer, but more specifically for cell phone versus non-cell phone users. So the set of all subjects developed brain cancer who were cell phone users. So let's copy that for the next sentence there, more specifically, who are non-cell phone users. Non-cell phone users. So there's the experiment group, then the control group there. The experiment group is going to be P sub 1. Again, we don't know what that number is. The best we have is a sample to get a picture of the population proportion for population number 1. But we do know for population number 2. In fact, for the null hypothesis, we're going to assume that both of those are equal. But the researcher wants to show that it's greater, that for that first group, the cell phone users has a greater rate of brain cancer than non-cell phone. So to grab that number that's in that next sentence there, this claim here, given, I know there's a couple of percentages, and that's usually the problem here for this. One of the percentages is level of significance, but the other one is going to be the claim. So be careful not to confuse that number with the level of significance, the 1%. That number there, that's alpha. And we'll start to use that in step 3. So, but this one's P2 at 0.5%. Recognize that that as a percentage could be converted into 0.005 as a decimal form. So either one of those would be acceptable here at this step. So we're going to say that P1 is 0.5%, yet we're going to try to prove it's more than that because of cell phone users. So let's go ahead and verify the requirements before we move forward here so that we know we can use the standard normal distribution. So the formula for all of these, this is n times P2 needs to be greater than or equal to 5, and n times Q2 needs to also be greater or equal to 5. So n in this, let's go up to the first sentence there. It says, let me move this over just a little bit, 1,375 and 11. So we want that 1,375. That's the n value for the study. But we want to multiply that times the claim, the 0.5%. So 1375 times 0.005 versus its complement, 1375 times 0.995. Let's grab a calculator and multiply. $13.75 times 0.005, 6.875 versus, for the other side, let's go ahead and multiply 1375 times 0.995, 1,368.125. 1,365.125. Correction, 1,368.125. Each one of those greater or equal to 5. We have met the requirements. They both have to be true in order to state the standard normal distribution. Standard normal distribution. Okay, now what we're going to do, take that information and apply that over next door. So the distribution that we're going to use here, I know for the other sections we claimed it was T. We're basically using the same thing, but we'll pretend that that's a standard normal distribution. For significance here, up at the top, we're assuming that alpha is equal to 1%. Of course, when we grab GeoGebra, we'll use 0.01. Now we need to determine, is this a left tail, right tail, or is this a two-tailed test? Looking at the research hypothesis, the arrows pointing to the right. So this will be a right tail test. More particularly, using the verbiage there, the word greater. Right tail. We want to be on the greater side, the right side. So right tail test. And mu is equal to 0 and sigma is equal to 1. So we'll recognize those are the settings there. More particularly for the right tail test, we want to grab that bracket on GeoGebra facing to the right. Okay, so let's go ahead and open up GeoGebra. Okay, there's a normal calculator. Let's grab that right bracket there, placing in the 1%, 0.01, 2.3263. Again, 2.3263 is a cutoff point for significance. We want to be beyond that point to reject the claim. .3263, and that's equal to Z naught. Shade to the right of that is going to be our 1% shaded. In the middle, we'll recognize on trial is the claim, the 0.5%. Can we show, because of the cell phone users, it's a lot more than that who had developed brain cancer? Let's write down the statistics to the problem for step number 4. The sample size is equal to 1,375 subjects p hat x over n, which we know is 11 of those. So what we want to do is take 11, divide that by the 1375. .008. So we'll end up standardizing that number and seeing if we have something significant. I want to standardize the .008 and turn it into a z-value that can compare to our cutoff point. So z is equal to .008 minus the claim, 0.005, divided by square root, grabbing the claim there, 0.005, in decimal form times its complement, 0.995, divided by the 1375. So matching up all the components here, again to iterate all the different parts, we have p hat versus p2 minus p2. Down there at the bottom is also p2 inside the square root with along its complement q2 divided by n. Let's grab a calculator. First start off with parentheses, 0.008 minus 0.005, giving us positive 0.03. Now what I want to do is divide that by parentheses 0.005 times 0.995 divided by 1,375, close parentheses, square root that, and then equals. So you should get 1.5772, 1.5772, thus saying that the 1 and the 6 rounded that 4 decimal places there for the critical value. So 1.5772. Is that significant enough to reject the claim? We'll go and look here. It's about halfway between 1 and 2. At that point, that's not enough for a significance. It's not in the rejection region. Therefore, the 0.008 or 0.8% is not any different than the 5%. Therefore, the cell phone users don't stand out to be anything different than non-cell phone users. So both percentages are statistically the same. Therefore, because it's not in the rejection region, we're going to fail to reject the null hypothesis. Now for the p-value, because we did a right-tail test, probability that z is to the right of that answer we got from step 5, 1.5772. Let's jump back over to GeoGebra. Right-tail test, then that middle box there, put in the 1.5772. Click in the bottom right box there, that's the p-value, that's more than 1% at 5.74% or 0.0574. Point 0.574. 5.74%, that's not less than the level of significance. We make the same conclusion, fail to reject the null hypothesis. Since the null hypothesis, and we are failing to reject it, the null hypothesis says that they're both equal. We didn't have enough evidence to show otherwise. So that'll do it here. For this example number 3, 9.4, hypothesis testing for a single population proportion.